All right, today's lesson is on multiplying monomials. All right, guys, so before we even start getting into that, let's make sure we understand what we're looking at with this term here, okay? The x, right, we know that's our variable, but when it has an exponent on it, we actually call this our base, all right? It's the base for this exponent up here, all right? So our goal today is to figure out what happens when we multiply two of these kinds of figures. So if you look at the next part right here, right, we're going to describe the rule. We've got x to the power of a, and we're multiplying it times x to the power of b. Now this formula is on your formula chart, the yellow one that you guys have on star. So this is not one that you have to memorize, but hopefully you get enough practice with it that it comes pretty naturally. All right, when you multiply the two monomials together, your product is going to be x to the power of a plus b, right? So your base stays the same, but your exponent becomes the sum. So even though you're multiplying the bases, you actually are adding the exponents, all right? So let's look at one example, and I'm going to do this example a little bit longer than is necessary just to kind of demonstrate my point here. All right, so I'm going to do x squared in red, and I'm going to rewrite it as x times x, right? X cubed, we're going to do in a different color. How about green? And we'll say that's the same as x times x times x, right? So you're multiplying x together how many different times? Well, let's just count these up here. We've got 1, 2, 3, 4, 5, right? So that's going to be x to the power of 5. You multiplied it times itself 5 times. And how many x's were there? Or not, sorry, we already talked about that. How many, what would we have gotten if we had added these two? Right, that also gives us 5. So it's kind of a quick demo of how this works. Okay, when we're looking at the next one, we've got something kind of strange going on. We've got x to the power of 3 times y to the power of 7. Well, we cannot add these exponents, right? We cannot add the 3 and the 7. Okay, I'm going to write this down here. I'm going to write can't add because the bases are different, right? The bases are different. So we can't just add them up. All we can actually do is just keep them separated. It's just going to stay x cubed y to the power of 7. Right, so this one that we did above, we were able to add them together because our bases were the same. Problem 2, we couldn't do that because they were different. All right, problem 3, we have something kind of similar to problem 1, except this 2 is in the front here, and that's called a coefficient, let's remember. This next term doesn't seemingly have a coefficient, but we can put a 1 right here if it helps us think about it. So we're going to multiply the 2 and the 1 because they're both coefficients, right? We're going to keep them together. It's going to give us 2. And then we're going to have x. We're going to be able to add up our exponents again this time because they have the same base. And it's going to give us 3 plus 6. Right? So our final answer for this one is going to be 2x to the power of 9. Problem 4, here we go. This one looks a little bit more difficult because you got more stuff, right? Just remember that x's go with x's, y's go with y's, coefficients go with coefficients. Also, something we haven't really talked about yet is, for example, look at this x right here. It does not have an exponent. So we're going to do ourselves a favor, or we're going to write a little 1 right here just so we don't forget it when we're counting them up later, all right? The same thing for this y in that second group. All right, so let's multiply 2 times 4. We know that's 8, right? And now we're going to look at our x's. We've got x to the power of 1 in the first group and to the power of 2 in the second group, so those are going to get added. And then we've got our y's, 3 in the first group, 1 in the second group. So our final answer here, when we can add those up, we're going to get 8x to the power of 3 and y to the power of 4. The most common mistake in these kinds of problems is students forgetting that these 1's are here, right? Don't forget those 1's are there. They have to be added to your final total. All right, problem 5, here we go. This one has got x's in the first one, x's in the second one, but also a y over here. All right, let's not let that throw us off. Put a little 1 on our x so we don't forget it. And here we go. We're going to multiply our coefficients again. 2 times 3 we know is 6. Then we've got x to the power of 4. We're multiplying it times the next group, which means, remember, the exponents are actually getting added. So we're going to do plus 1. And then we have this y to the third power. That just stays the same, right? Nothing's getting added to it. Nothing's combined with it because it has a different base. So we're going to have 6 x to the power of 5, y to the power of 3. All right, 2 more. Here we go. The only thing different here from the ones we've seen earlier is we got a couple negative signs. We're going to deal with those the same way we've always dealt with them. They shouldn't be too bad. Let's throw a 1 right here on the x. We're going to get started. All right. Even though it's negative, we can still multiply it times our constant, our coefficients. So negative 2 times 4 is going to give us negative 8, right? And now the parentheses, nothing's between the parentheses, right? Remember, that does indicate we are still multiplying. So the x to the power of 2 in the first group and x to the power of 1 in the second group. So those are going to get added. And we've got y to the power of 3 and y to the power of negative 3. So remember, I'm still going to add, but I'm going to add a negative 3. All right, so let's clean up our answer here. We've still got negative 8 in the front. We've got x to the power of 2 plus 1, which is 3. And we've got y to the power of 3 plus negative 3. Well, 3 plus negative 3 is 0. All right, if we get y to the power of 0, any base to the power of 0, it actually turns into the number 1, right? We talked about this a little bit earlier, which I don't need to write, okay, because if I'm multiplying by 1, it's staying the same. So my final answer here would be negative 8x cubed, right? The y went away, right? It kind of got canceled there. All right, problem 7. Problem 7, we are dealing with some distribution, right, in the midst of our exponent rules here. But we've already learned this. We can do this. Here we go. Let's do the first one. Let's focus. We're just going to write it out. So we're going to do 3x times x squared. And then we're going to do plus 3x times 4. All right. Okay. So let's clean that up here. We're going to get a little 1 on this one. So this is going to become 3x to the power of 1 plus 2. Plus, in that next group, the 3 and the 4 are both constants. They can be multiplied. Then we get 12. There's only just the 1x, so it's going to stay the same. So our final answer here is going to be 3x to the power of 3 plus 12 to the power of x. Now remember, do not try and combine these two terms that we're left with because they are not like terms. So we have to leave it just as it is. All right, make sure you ask me if you have any more questions regarding this lesson.